Hey kids, Flexing Teacher Weber here. I hope you're having a good day. Today we're going to look at another topic in algebra called the distributive property. It's not just an algebra topic, it's a topic that deals with numbers in general, but it's important in algebra as well. And it's something you've probably done before or known about before, but it's again something you've never looked at formally or given it a name to. So what we're going to do first is we're going to study some simple facts related to the distributive property, and then apply them to some algebraic expressions. So what I want to do first here is look at a simple math fact, 4 times 7. And 4 times 7, we know, is 28. But what the distributive property says that I can, instead of multiplying two numbers, I can multiply the number as the sum of its parts. So let me show you what I mean. Maybe I could do this. Instead of doing 4 times 7, I could do 4 times 5 plus 2, because 5 plus 2 is 7. And I'm going to use use parentheses to represent times. Now, just to show you the meaning of this means 4 groups of 5 plus 2. So I could do this. I could do 5 plus 2, 5 plus 2, 5 plus 2, 5 plus 2, 4 times. And add those up, and I get 4 groups of 5 is 20, and 4 groups of 2 is 8, and that's equal to 28. So the distributive property says I can multiply a number times the sum of its parts, or the difference of its parts. Now, a short way of doing this is to just multiply the 4 times the 5 and the 4 times the positive 2. So I could also do this. I could say, you know what? This is the same as 4 times 5 plus 4 times 2. And that's equal to 20 plus 8, which is equal to 28. All right? So the distributive property says I can, take a number, break it into its parts, multiply by those parts, and I'll still get the same answer. So using another example, 3 times 498, here's where the distributive property might help you. Instead of doing 3 times 498, maybe I'll do 3 multiplied by 500 minus 2. And that's like saying 3 groups of 500 minus 2. So I could do this. I could do 500 minus 2, 500 minus 2, 500 minus 2. And I could total those up. Well, 3 groups of 500 is 1,500. And 3 groups of negative 2 is negative 6. And when I total that up, that's 1,000, or when I subtract that, that's 1,494. So in this case, the distributive property can actually take a harder question and make it a lot easier. Now, really what we're doing is we're multiplying the 3 by each of the parts of this difference. So what we're really doing, another way of saying this, is we're doing 3 times 500 plus 3 times negative 2. We're multiplying the 3 times positive 500 and the 3 times negative 2. And when we do that, we get that that's 1,500 plus negative 6, and that's equal to 1,494. Okay? So it's just interesting to see how you can manipulate numbers, and the distributive property lets you to do all sorts of fun things with numbers. So that's looking at the distributive property with whole numbers. Let's look at it with algebra expressions and apply the same thing here. So this first algebra expression, 3 multiplied by y plus 2. If we want to expand this expression and get rid of the brackets, we can think of this as 3 groups of y plus 2. So y plus 2, y plus 2, y plus 2. 3 groups of y plus 2. And remember, if there's no coefficient in front of the variable, there's ones in front. Now, yesterday we were working with like terms. So now we can group up our like terms. We have 3y's and we have plus 6. And that's as simple as you can make that expression now. That expression is 3y plus 6. Now, what the shortcut version of this, or what the distributive property is really saying, is you're doing 3 times y, so 3 times y, and you're doing 3 times positive 2, so plus 3 times 2. And that's equal to 3y plus 6. So the way we would use the algebra, or the distributive property in algebra, is to simplify an expression and make those parentheses go away. It's called expanding it. Let's do another one. 4 times x minus 7, or a better way of saying this is 4 groups of x minus 7. So I could think of this as x minus 7 plus x minus 7 plus x minus 7 plus x minus 7. Total those up. Remember, this is like 1x. So I have 4x. And then I have negative 7, negative 14, negative 21, negative 28. So that's 4x minus 28. If I want to think of this in a shortened version, I distribute the 4 to the x, and I distribute the 4 to the negative 7. So this would be like 4 times x plus 4 times negative 7, remembering that the sign in front of the integer always goes with the integer. So this is going to be 4x, and that's plus negative 28, or a simpler way of saying that is just 4x minus 28, which is exactly what we got down here. This is sort of the long version showing you what it means, and this is sort of the shortcut to expand that expression and make the parentheses go away. Let's look at some different examples. Okay, negative 5 multiplied by n plus 6, or negative 5 groups of n plus 6. What this means is 5 groups of n plus 6, but the negative sign means to do the opposite of each term. So I'm going to have negative n, and the opposite of plus 6 is minus 6. And I'm going to have that a total of 5 times. The negative sign on the 5 makes everything the opposite. And remember, this is like saying there's ones in front of these. So this is like saying, if I group up my like terms, negative 5n, and then negative 6, negative 12, negative 18, negative 24, negative 30. So negative 5n minus 30. Now the shortcut of this is to multiply negative 5 times n and negative 5 times positive 6. So it's to do this. Negative 5 times n plus negative 5 times positive 6. And when you do that, you get negative 5n plus negative 30. Or a better way of saying that is just negative 5n minus 30. The same way, right? You get the same answer the same way. This is sort of the longer version. This is sort of the shortcut. But it's all using the distributive property. It's distributing the negative 5 to everything that's in the parentheses, each term in the parentheses. The negative 5 is being distributed to each term. Okay, and you can have 3-term expressions. Now this is 3 groups of negative 1x plus 2y minus 7. So I could think of it like this. Okay, negative 1x plus 2y minus 7. and do that 3 times. And then group up my like terms. Group up the terms that are the same. So I have negative 3x. I have positive 6y. I have negative 7, negative 14, negative 21. And now I've expanded that expression and distributed the 3 to each term in the expression. And that's what that means, is distributing the 3 to every term in that expression. Now, if I do the shortcut of this, I do 3 times negative x, which is negative 3 multiplied by x. And I do 3 times positive 2y, which is plus 3 times 2y. And then I do positive 3 times negative 7, so plus 3 times negative 7. And when I do those multiplications, I get negative 3x plus 3 times 2 is 6y, plus 3 times negative 7 is negative 21. And that's just the same as saying negative 3x plus 6y minus 21. You get the same answer either way you do it. We're distributing the 3 to each term in the parentheses. Let's look at one last question. Negative 2 multiplied by 2x plus 3y minus 6. So once again, this negative sign means we're going to apply that negative to each term in the parentheses. So it's going to be 2 groups of what's in the parentheses, but the opposite of each term. So this is going to be negative 2x. The opposite of plus 3y is minus 3y. And the opposite of negative 6 is plus 6. And we're going to do that 2 times. So negative 2x minus 3y plus 6. 2 groups of what's in the parentheses, but the opposite of each term. Now we total that up. Negative 4x. These two make negative 6y. And these two make positive 12. So that's the simplified version of that expression, making the parentheses go away. Now, if I was to do this by just distributing the negative 2 to each term, so this means negative 2 times 2x plus negative 2 times positive 3y. And then plus negative 2 times, remember this is a negative 6, negative 2 times negative 6. And if we multiply each term, negative 2 times 2x is negative 4x, plus negative 2 times 3y, so negative 2 times 3y is plus negative 6y, and then plus negative 2 times negative 6 is positive 12. Now, a simpler way of saying this is just negative 4x minus 6y plus 12. And you get the same thing either way you do it. That's called using the distributive property and distributing the negative 2 to each term in the parentheses. We use that in algebra and to simplify algebraic equations. And that's what you're going to do today. You're going to practice simplifying algebraic expressions by distributing, using the distributive property to make the parentheses go away. I hope that helps. That's the distributive property. That's all for now. Flexing Teacher Weber out.